right, so we are looking at section 8.5 today. In your notes for section 8.5, you've got matrices A, B, C, D, and E that I want you to go ahead and enter into your graphing calculator. I've already shown you how to enter matrices into your calculator before, but just for review, there are actually two different ways that you can put them in your calculator. If you are going to use the same matrices over and over again, like we're going to do today, it would be better to put them in the matrix menu. So the way that you can do that is go to Second and then Matrix, go over to Edit, and I'm on A, so it's going to edit matrix A. So I can go in here and tell it anything that I want to. Like I can tell it that I want to do a 3 by 2, and you'll notice that then it will set up a 3 by 2 and I can just start typing the numbers on top of it. What I want for matrix A, however, from your notes is a 2 by 2. So I'm going to tell it 2 by 2 and it'll give me the 2 by 2 there. And so the one that I want you to put in is what you see here, 3, 2, 1, 4. So we would just do 3, enter, 2, enter, 1, enter, 4, enter. All right. Then we can quit out of that and go back to matrix again. And if I wanted to enter another matrix, as we do, then I would just go to a different matrix. Like I could go to matrix B and choose edit. And so for matrix B, I had asked you to put in this 2 by 3, 1, negative 2, 5, 0, 3, negative 1. All right, then we want to go back to matrix again. And I had asked you to put in this for matrix C. Matrix C is a 3 by 3. So this is the matrix that we want for C, 1, 0, 1, 2, 2, 1, 4, 3, 1. And then for matrix D, for matrix, oh, just kidding. For matrix D, we want to edit, not names. So for matrix D, we want the 2 by 2 identity matrix, 1, 0, 0, 1. And then the last one for matrix E, what I had asked you to put in on your note sheet was a 3 by 4. And so it was negative 1, 2, negative 3, 1. 2, 0, 1, 0, and 3, negative 4, 4, 2. Now, if you were not going to be using the same matrices over and over again, if you have an 84, remember that you have a dedicated matrix button on your calculator. So you could do alpha zoom, which is your matrix menu, and then you could choose, like, let's say that I wanted to put in a 2 by 2, that matrix A that we are working with today. When I do that, it'll lay out a 2 by 2 on my screen for me. Do not hit enter though to go to the next number like we do in the matrix menu. Just use your arrow button. So I would do 3 right arrow, 2 right arrow, 1 right arrow, 4 right arrow. So if I just was going to use that matrix one time, that'd be a fast, easy way to there add it or subtract it or find the inverse or the determinant or something like that. Okay? So I want to go back and show you how to do everything that we have learned to do by hand now on your calculator. All right, so let's start with the first thing we did was matrix addition. So let's say that I want to add matrix A and matrix B. Matrix A is a 2 by 2, matrix B is a 2 by 3. Can I add those? Can you add a 2 by 2 and a 2 by 3? No, why no? Their orders are not the same. You can only add and subtract if you have the exact same order. My calculator knows that, and it'll tell me that. So for instance, if I go back to matrix and choose names A, and then ask it to add, go back to matrix, and choose names B. So I'm going to ask it to add matrix A and matrix B. It'll give me an error message. And not only does it give me an error, but it gives me a clue to what's wrong. It says, hey, your dimensions don't match. To add and subtract, your dimensions have to match. Okay? Would I be able to would I be able to add matrix A and D? Yeah, because their dimensions are the same. Now, let's save ourselves a little bit of time and energy. Remember that if you hit second enter, it'll retype the last thing, or you can, if you have an 84, you can scroll up and choose the last item that you had and hit enter again, and it'll let you go type back on top of that. So I can come over here and type on top of matrix B if I want to add A and D, and that just saves me some time and energy, particularly if I'm doing a bunch of these. So you told me I should be able to add A and D, and there was no problem with that at all. I also then should be able to subtract, right? Because their order is the same. So again, I'm going to do second enter, or I'm going to scroll back up to grab that last entry, and I can come over here and just put a subtraction sign on top of my addition sign to save me from having to go grab those names again off of the matrix menu. All right, what about multiplication? Should I be able to multiply matrix A and D? Yeah, because their order is the same. What is matrix D? It's the identity matrix. So if I multiply A times D, what should I get? Close. If you multiply a matrix times the identity, what should you get? The exact same thing you started with, right? So if I multiply matrix A times matrix D, and D is the identity, what should I get? Matrix A, exactly. So let's see. Again, I'm going to do second enter to get my calculator to retype that for me, so I can just run back over here and put a multiplication sign on. And when I multiply A times D, sure enough, I just get matrix A like you told me that I would. All right, can I multiply A times B? Yes, but are you sure their order is not the same? That's a 2 by 2 and a 2 by 3. So you can't multiply if the inside numbers are not the same, but the whole order does not have to be identical. So in addition and subtraction, the order has to be identical. In multiplication, only the inside numbers have to be the same, but your order does not have to be identical. So if I wanted to multiply A times B, A is a 2 by 2, B is a 2 by 3, those inside numbers are the same. I will be able to do that. So again, I'm going to hit second enter and just retype on top of matrix D, matrix B. And sure enough, like you said, we were able to multiply there. We didn't get an error message. Is A times B the same thing as B times A? Because the next thing it says is multiply B times A. Shouldn't it just be the same answer? No. A plus B is the same thing as B plus A. A times B is not the same thing as B times A. So if I try to do matrix B times matrix A, nope, not that. Not only is it not the same thing, it can't even be done, right? I get another one of those error messages that say, hey, there's something wrong with your dimensions. What's wrong with my dimensions? Inside numbers are not the same, right? So I can't do that. Okay, so that was adding, subtracting, and matrix multiplication. The other type of multiplication that we did was scalar multiplication, like 2 times B. So let's go through and do 2 times matrix B. That basically should just double every value in our matrix. And it does. And then we also did the inverse of a matrix. Now, I showed you how to do the inverse on a matrix on your calculator before, but just for review today, you can only find the inverse of what kind of matrix? Square, yes. So only a 2 by 2, 3 by 3, something like that. So will we be able to find the inverse of C? Yeah, because it's a 3 by 3. It is an inverse. So let's go grab matrix C. And we'll do the inverse of matrix C, again like we did earlier in this chapter. We've done these on the calculator. It did not look like that when we did this before. Okay, well, what this is giving me is a decimal answer. Like you can see, negative 0.3333, that's just 1/3, right? And see the arrow over here on the right hand side? That means that if I use my right arrow key, there's more over here. And so sure enough, if I scroll over, there's my second column, there's my third column, and that third column is all repeating decimals as well. What would be a whole lot easier is if this was in fraction form instead of decimal form. Okay, just tell your calculator to switch it to a fraction. If you go back to your math button, you can tell it, that very first option up there, you can tell it to change it to a fraction. So choose that very first one, and it will change that matrix over to fraction form. Then you can see the whole thing at one time, and it's easier to work with. All right, then the determinant of matrix C. Can you find the determinant of a square matrix? Does a matrix have to be square to find the determinant? Yes. So we could only find the determinant of a 2x2 or a 3x3. So let's stick with matrix C. So I'm going to go back to matrix and use a menu that we've not used yet. Let's use the math menu. That very first button up there, determinant, DET, that's what that is, determinant. So I'm going to choose determinant, and then I'm going to go back and grab matrix C. So if I ask it to find the determinant of matrix C, okay, you got to appreciate this, right? Matrix C is a 3x3. Think about how long it took you to do a 3x3 on your homework last night with minors and cofactors or with diagonals, and then hit enter on your calculator. Like fraction of a second, right? That's crazy. So there's the determinant of C. And kind of keep that one in mind, that -3, because we're going to use that in example number 1 in the problems in just a second. And I'm going to say that's the answer we got from our calculator. All right, last thing that we want to look at is reduced row echelon form on the calculator. All right, you remember when we were doing like on the homework, number 32, where we were putting a problem in row echelon form, okay? So row echelon form was when we were trying to get the 1, 0, 1, 0, 0, 1. Reduced row echelon form is when we would have to find the other zeros as well, right? Takes like half a sheet of paper at best. Not a whole lot of fun. Your calculator will do row echelon form and reduced row echelon form for you. Now remember, we've talked about before, row echelon form is not unique. So number 32 on the homework that we were just working on together, if you put that matrix in your calculator and you hit the row echelon form button, it would not give you the answer that we just got together a few minutes ago, because there are lots of different answers for row echelon form. So we're not going to use that button. But there is only one reduced row echelon form. It is unique, so I happily want to use that button on my calculator. So let's go back to matrix and go back to math. It's actually faster to scroll up to it because it's near the bottom of the menu. So I'm going to scroll up and you can see it right there. B is reduced row echelon form. Grab that. And then grab matrix E. Matrix E would be an augmented matrix for a system. It was a 3x4. And so it will put that in reduced row echelon form for me, again, in a fraction of a second. And again, if I would rather have it in fraction form, then I can ask it to switch it over. Okay? So the things that we looked at on the calculator, we looked at A plus B gave us an error statement because a 2x2 and a 2x3 can't be combined. We saw that when we multiplied A times D, we got the exact same thing we started with because D was the identity. And we saw AB was not the same thing as BA.